नमस्कार विद्यार्थी मित्रों, सीईटी मॅथमॅटिक्स मॉडेल पेपर 2 यासाठी मी 5 भाग बनवलेले आहेत. त्याच्यातला आता पहिला भाग तर बघूया आपण. फर्स्ट पार्ट सीईटी मॉडेल पेपर 2. Now our first question is, if I is equals to integral 0 to k dx upon in under root of 4 minus x square is equals to pi by 2, then what is the value of the k? Now see this integral. I is equals to integral 0 to k dx upon in under root of 4 minus x square. Now this is the integral of the type that is a dx in under root of x square minus x square is equals to sine inverse of x upon e plus c. Now in the same way, that is we have the integral value, it is a pi by 2 equals to sine inverse of x upon 2 0 to k. Now what is the upper limit? The upper limit is k. Therefore, sine inverse of k by 2 minus sine inverse of 0. The value of the sine inverse of 0 is 0 and the sine inverse of k by 2. Now next, that is pi by 2 is equals to sine inverse of k by 2. Therefore, sine of pi by 2 is equals to k by 2 and the sine 90 is 1 and therefore 1 is equals to k by 2 and the value of k is 2 and hence the option D is a correct one. Now next, the next question is from the equation of the circle. The parametric representation of the circle 3x square plus 3y square minus 4x minus 6y minus 4 equals to 0 is. Now first of all, see this, the equation, the given equation after dividing by 3 can be written as, that is, we make the first of all the coefficient of x square and y square as it is 1. Therefore, x square plus y square minus 4 by 3x minus 2y minus 4 by 3 equals to 0. Now again this can be written as, that is x square minus 4 by 3x plus y square minus 2y is equals to 4 by 3. Now to make this perfect square, the middle term is a 4 by 3x. Then what will be the second term? That is 4 by 3 divided by 2. Then you will get 2 by 3. Then add here, that is the square of the 2 by 3, which is a 4 by 9 plus. Now this will become the perfect square and it is a square of x minus 2 by 3 bracket square. What about the second? That is a y square minus 2y. Then what is the second term? That is the middle term divided by 2. Then you will get minus 2y upon 2, that is 1, and 1 will be the second term, that is 1 square. Therefore, you will get, that is y square minus 2y plus 1. This is the perfect square. It's a square of the y minus 1 bracket square. Now we are adding the 4 by 3 and the 1 on the left hand side at the same time, that is 4 by 3 to the right hand side, 4 by 3 plus 4 by 9 plus 1. Now this is the perfect square, that is a y minus 1 bracket square. Now it is a square of, that is a x minus 2 by 3 bracket square plus y minus 1 bracket square is equals to 25 by 9. Comparing the equation with x minus h bracket square plus y minus k bracket square is equals to r square. This is the equation of the circle, center, radius form. There are the 3 types of the equation of the circles. One is a standard equation. First, that is the standard equation means what? It's a center is 0. And therefore its equation is a x square plus y square is equals to r square. Second is the equation, that is center radius form. The center radius form is a x minus h bracket square plus y minus k bracket square is equals to r. And last is diameter form, that is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. And that is, we can solve that diameter form. Now next, we have this equation, that is x minus h. Here is h is 2 by 3, k is 1 and r is 5 by 3. The parametric representation of the circle is x is equals to h plus r cos theta and y is equals to k plus r sin theta. Now it can be written as, substitute the value, x is equals to 2 by 3 plus 5 by 3 cos theta and y is equals to 1 plus 5 by 3 sin theta, and hence the option A is a correct one. Now next question is from the integration, that is I is equals to integral cos of 2x minus cos of 2 alpha upon cos x minus cos alpha dx. Now evaluate this integral. We can evaluate in this manner, that is I is equals to integral cos of 2x minus cos of 2 alpha upon cos x minus cos of alpha dx. Now what is the formula for the cos of 2x? That is the 2 cos square x minus 1. And the cos of 2 alpha can be written as 2 cos square alpha minus 1. Now evaluate this, that is here is a minus 1 and it becomes the plus 1. Plus 1 and minus 1 get cancelled. Now here is a 2 cos square alpha minus 2 cos square x minus 2 cos square alpha. Take the 2 as common, then you will get cos square x minus 2 cos square x minus 2 cos square alpha. After taking the 2 as a common, then you will get cos square alpha, cos square x minus cos square alpha. That is the cos of x minus cos of alpha in first bracket, and in second bracket cos x plus cos alpha. Then minus minus get cancelled. Then you will get the next. Now here as 2 is common, that is integral cos square x minus cos square alpha upon cos x minus cos alpha dx. Now we can split up, that is a cos x minus cos alpha in first bracket, second bracket cos x plus cos alpha. Now minus minus get cancelled, that is a cos x minus cos alpha to the numerator, and the denominator cos x minus cos alpha get cancelled, and you are getting, that is a 2 integral cos x plus cos alpha dx. Now integral of the cos of x is the sin x, and what is this? Cos alpha is a constant term, is treated as it is. But the integral of the dx is x and multiplied by 2. Therefore, it becomes a 2x cos alpha plus c. Therefore, our answer is, that is a 2 sin x plus 2x cos of alpha plus c, and hence the option C is the correct one. Next. Now next question is from the implicit derivative, that is x raised to y is equals to e raised to x minus y. Then show that what is the dy by dx equals to. Again, this very interesting problem, that is x raised to y is equals to e raised to x minus y. Take log on both sides, then you will get log of x raised to y is equals to log of e raised to x minus y. Now this is the exponent we can write in this manner by using the rules of the logarithm. That is y log of x is equals to x minus y. Log of e to the base e, the value is 1. And therefore, that is the y log of x is equals to x minus y. Now differentiate this with respect to x. That is the y log of x. That is y into log of x. Derivative of the log of x is 1 by x plus log of x into derivative of the y is a dy by dx equals to 1 minus dy by dx. That is, you will get y upon x log of x into dy by dx plus dy. This minus to the left hand side, it becomes the plus dy by dx equals to 1. Now collect the terms of the dy by dx, and then you will get the dy by dx. Now here y upon x plus 1 plus log x into dy by dx is equals to 1. Therefore, keep this 1 plus log x into dy by dx to the left hand side and y upon x to the right hand side. It becomes minus. Now simplify this. That is 1 into x. That is x minus y upon x. But we require the dy by dx. Therefore, dy by dx is equals to x minus y upon x in bracket 1 plus log x. Now again, that is, we substitute here the value of, here we substitute the value of x minus y is y log x, and the value of x is y plus y log x, and 1 plus log x as it is. Therefore, you are getting the y log x. Take y as common, then you will get, that is y in bracket 1 plus log x into 1 plus log x. Now this y get cancelled, and then you will get, that is a dy by dx is equals to log of x upon 1 plus log x in bracket square, and hence the option B is correct one. Now the next question is from the function, that is, it is from the 11th standard. That is, if f of x is equals to cos of log x, then f of x into f of y minus 1 upon 2 f of x upon y plus f of x into y is equals to. Then what is value? Now see this, that is f of x into f of y minus 1 upon 2 f of x upon y plus f of xy. Now we have the function f of x is equals to cos of log x. Therefore, we are replacing here the value f of x means what? Cos of log x. F of y means what? cos of log of y minus 1 upon 2 f of x upon y can be written as, that is the cos of log of x upon y plus f of xy means what? Cos of log of xy. Now this can be written as, that is equals to cos of log x into cos of log of y minus 1 upon 2, that is the cos of log of x upon y. It can be written as cos log of x minus log of y plus cos of log of x plus log of y. And after the simplification, that is you will get cos of x dot cos of log of y, that is minus 1 upon 2, and you will get, what is this? This is a cos of a minus b plus cos of a plus b. After simplification, you will get, that is a cos of log of x into cos of log of y plus sin of log of x into sin of log of y plus cos of log of x into cos of log of y minus sin of log of x into sin of log of y. That sin terms get cancelled, and that's why you are getting the first term, that is a 2 times cos of log of x into cos of log of y. And now these two get cancelled, and overall the whole answer is 0, and hence option D is the correct one. Now next question is from the continuity. It's again very simple question. If the function f of x is a continuous in an interval minus closed interval minus 2 to 2, find the values of a cube plus b cube where f of x is equals to sin ax upon x minus 2. The value of the x lies between 2 minus 2 and the 0 or equal to 2. And f of x is equals to 2x plus 1 for x lies between or equal to 0 to 1. And the f of x is equals to 2b in root of x square plus 3 minus 1 for x lies between 1 and 2 and equals to 2. Then what is the value of a cube plus b cube? Now as given function is a continuous, therefore the value of the function is equals to the limit of the function. Now this is again very important, that the given function break at the 2 points. It break at the 0. It breaks at the 1. Therefore we will find out the limit of function left hand side and the right hand side at the 0. That is the limit x tends to 0 minus, it means that it is a left hand side limit, and this is a right hand side limit, that is the limit x tends to 0 plus, it is a right hand side. Then equate it. Find out the value at x is equals to 0. That is we take here. That is a 2 into 0 plus 1. That is you will get the value of the function is 1. And then at the same time for the next, the function breaks here that the 1. मी प्रत्येकदा इथे असं डिफाइन करणार आहे की फंक्शन कुठे ब्रेक होतो, फंक्शन कुठे चेंज झालेला आहे, तर तो 0 ला चेंज झालेला आहे. म्हणून 0 चं लेफ्ट लिमिट आणि राइट लिमिट फाइंड आउट करा, आणि 1 ठिकाणी पण तो फंक्शन ब्रेक झालेला आहे, म्हणून 1 ला देखील त्याचं लेफ्ट हँड साइड लिमिट आणि राइट हँड साइड लिमिट फाइंड आउट करा. देन यू विल गेट द व्हॅल्यू ऑफ द ए बी and you can find out a cube plus b cube. Now see this, the f is a continuous in a closed interval minus 2 to plus 2. F is continuous at x is equals to 0 and x is equals to 1. Now we'll check the continuity at the 0. It's a breaking point. Therefore at 0, limit x tends to left hand side, f of x is equals to limit right hand side as x tends to 0, that is equals to f of 0, and limit x tends to 0 sin of ax upon x minus 2, limit x tends to 0 to x plus 1 and f of 0. Now what is your sine angle is ax, therefore we adjust here a to the denominator multiplied to the numerator minus 2, and the value of this limit is 1 into a, that is a minus 2, and the limit of this as x tends to 0 is 1, and the value of the function is also 1, because if we substitute x is equals to 0, then 2 into 0 is 0 plus 1, and overall it is 1. Then what's happening here? That is the value, that is 1 into a, it becomes a, minus 2, it becomes plus, therefore a is equals to 1 plus 2 is equals to 3. This is the value of the a. Now we'll find out the value of the b. To find out the value of the b, we take the function which breaks at the point 1. Therefore, C, the next limit. Now continuity at x is equals to 1, that is the limit x tends to left hand side 1 of f of x, limit x tends to 1 f of x right hand side, and its value at x is equals to 1. Therefore, for the left hand side limit x tends to 1 to x plus 1 and limit x tends to right hand side 2b in under root of x square plus 3 minus 1. Replace x as a 1, that is a 1 plus 3 is 1 plus 3 is again the 4 into. Now what is here? Therefore here as x is replaced by 1, that is a 2 into 1 plus 1. What about here? That is the x is replaced by 1, that is a 2b in under root of 1 plus 3 minus 1, and here 2 plus 1, that is a 3. Therefore you will get 2 plus 1, 3. Here 2 plus 1 is 3. But what is our m? That is a 2b in under root of, that is 1 plus 3 is a 4. Root of 4 is 2. That is, it can be written as, that is a 2b, again 2, that is a 4b minus 1 equals to 3. Then you will get the value, that is a 4b is equals to 3 plus 1, and that is equals to 4. Therefore b is equals to 4 upon 4, that is equals to 1. But again there is, we want to find out the value of a cube plus b cube. But what is the value of a cube? That is a 3 raised to 3 means of 27, and 1 cube is again 1, and that is equals to 28, and hence option B is a correct one. Now next question is from the higher order derivative. Also it is of the form of the parametric also. If x is equals to sin t minus b cos t and y is equals to a cos t plus b sin t, then what is the value of d2y by dx square? Now it's very simple again. X is equals to a sin t minus b cos t and y is equals to a cos t plus b sin t. Now differentiate x and y with respect to x. Now first of all, if we differentiate x with respect to t. Now derivative of the sin of t is a constant, that is a into ddx of the sin of t minus b into ddx of the cos of t. That is a cos t minus b, and the derivative of the cos of t is a minus sin t, and that minus become plus. Now next dy by dx is equals to a ddt of the cos of t minus b ddt of the sin of t, and we get that is a dy by dx is equals to minus a sin t minus b cos t. Now next, therefore dy by dx is equals to dy by dt upon dx upon dt, and we will substitute the value of dy by dt upon dx upon dt, that is a minus a sin t plus b cos t upon a cos t plus b sin t, and take the that is a negative sign from the common, then you will get that is a minus in bracket a sin t minus b cos t upon a cos t plus b sin t, and this is nothing but the minus x upon y. This is the value of the x and this is y. Now differentiate this again with respect to x. Now here that is a d2y by dx square, that is a minus ddx of x upon y. Now differentiate this, that is you are getting dy into, by using the quotient rule, y into ddx of x minus x into dy by dx. That is the derivative of the x is 1 minus x into, that is a dy by dx. The value of the dy by dx is a minus x upon y square, and simplify this, then you will get this is the y. Minus will become plus, y into y square plus x square upon y square into y, and it becomes minus x square plus y square upon y cube, and hence the option A is a correct. Now next question is also interesting. It's a pair of the straight line. The joint equation of the bisectors of the angles between the lines represented by 5x square plus 6xy minus y square is equals to 0. Now comparing this equation with our standard equation, that is 5x square plus 6xy minus y square is equals to 0, with ax square plus 2hxy plus by square is equals to 0, we get the value of the a is 5, 2b is 6, and the 2h is equals to 6 and b is equals to minus 1. Now next, let m1 and m2 be the slopes of the lines represented by this equation. Now find out the sum of the roots, that is m1 plus m2 is equals to minus 2h upon b, that is a minus 6 upon minus 1, that is equals to 6. And the products of the roots, that is m1 into m2 is equals to a upon b. that is a 5 upon minus 1, and that is equals to minus 5. Now next, now the separate equation of the line is, as line passes through the origin, it is of the form y is equals to mx, therefore y is equals to m1x and y is equals to m2x, where m1 is not equals to m2. Therefore, it is written as m1x minus y equals to 0 and m2x minus y equals to 0. Let P be the any point on one of the bisector of the angles between the lines. The distance of P from the line m1 x minus y equals to 0 is equals to the distance of the P from the m2 x minus y equals to 0. And therefore, that is, we find out the distance of the point, perpendicular distance of a point from a line, that is m1x minus y, by using the perpendicular distance formula. That is here m1x minus y upon in under root of m1 square plus 1, and that is m2x minus y upon in under root of m2 square plus 1. Now squaring the both sides, then we will get, after squaring we will get, that is a m1x minus y bracket square upon m1 square plus 1 and m2x minus y bracket square upon m2 square plus 1, and make the cross multiplication and simplify this, that is m2 square plus 1 in bracket. Now the expansion of this is written m1 square plus 1 and expansion of the second term is written. Now multiply on both sides and collect the terms of the x square plus the term of the xy and the term of the y square. Then we will get the values of the m1 minus m2 and m1 minus m2 bracket square. The m1 minus m2 bracket square can be again written as, that is a m1 plus m2 and m1 minus m2, m1 minus m2, m1 minus m2 get cancelled throughout. That is m1 minus m2 is not equals to 0. We divide it. Then you will get m1 plus m2 into x square plus 2 times m1 into m2 into xy minus 2xy minus m1 plus m2 into y square. Now we have the values of the m1 plus m2 and m1 into m2 and substitute, then we will get the, that is, after substituting the values you will get 6x square minus 12xy minus 6y square is equals to 0, and again divide by the 6, then you will get x square minus 2xy minus y square equals to 0, and hence option C is the correct one. Now next question is from the matrix, that is, if A is equals to 4, 5, 2, 1, then A inverse is equals to, what is the value of the A inverse? Now first of all, one thing is that here is the, we will find out it's a determinant, that is a 4 into 1, and next is 5 into 2, and that is the value of the, it's a minus 6. Now here is 1 by 6. Next find out it's a inverse. Then how to find? Then by using the inverse method we can find out it's a inverse. It's an easy question. That is, A inverse is equals to 1 by 6. That is A minus 5 times I. And now you verify, you will get the answer of this question. It's an easy one. You can find out the inverse of the matrix by the adjoint method and verify it. That is, A inverse is equals to 1 by 6, A minus 5I. Now next question is from the vectors, that is the coordinate of foot of perpendicular drawn from the point, that is a 2I minus j plus 5k to the line. R bar is equals to 11I minus 2j minus 8k cap plus lambda in bracket 10I minus 4j minus 11k cap. Then what is the coordinate of the foot of perpendicular from this point to this line? Now see this, let M be the foot of the perpendicular drawn from the point P, that is it. It's a position vector is a minus 2I minus j plus 5k to the line. This is the line. Let the position vector of the point be M. Now again this vector can be written as in terms of the ijk, that is a minus 11I cap minus 2j cap minus 8k cap plus lambda in bracket 10I cap minus 4j cap minus 11k cap. Now collect the coefficient of I, j and the k. Then what is the, that is the PM is equals to the position vector of the point M minus position vector of the point P. Now the position vector of the point P is 11 plus 10 lambda plus. The next is minus 2 minus 4 lambda j, and the last is minus 8 minus 11 lambda k minus the position vector of the given point, which is minus 2i minus j plus 2k. And after subtraction and the collecting the coefficient of I, j, k, you will get 9 plus 10 lambda I cap plus minus 1 minus 4 lambda j minus 13 minus 11 lambda k. Since the PM is a perpendicular to the given line which is parallel to B bar, and hence therefore PM bar perpendicular to B bar, therefore their dot product is 0, and hence that is we find out their dot product, and that is a 9 plus 10 lambda I plus in bracket minus 1 minus 4 lambda j minus 13 minus 11 lambda k cap dot. That is a vector P bar, that is a 10 I cap minus 4 j cap minus 11 k cap, and find out their dot product, that is equals to 0, and that is equals to, that is a 90 plus 100 lambda plus 4 plus 16 lambda plus 143 plus 121 lambda equals to 0, and after simplification you are getting that is the 23 lambda plus 23 equals to 0, and hence lambda is equals to minus 1. Putting this value of the lambda, we get the position vector of the n, that is a I plus 2j plus 2k cap, that is a 1, 2, 3, which is the position vector of the point n, that is the foot of the perpendicular 1, 2, 3. Now we have completed the 10 questions from the model paper 2. Now next we'll see the next 10 questions. Till then,